my clock has now switched to 3 o'clock. And I will say welcome here, everybody. Today, we have a visitor from University of Gothenburg, Alan Said, who will be talking about recommender system. And very much welcome here, Alan, and the floor is yours.
Thank you. Right, so I will be talking about recommender systems. Specifically, I'll give you a historical recap of what recommender systems are and how they work and so on. Before I start, let me just tell you a bit about who I am. I'm an associate professor at the University of Gothenburg at the Department of Applied IT. In the past, I've worked in academia and industry in Sweden and abroad, and I've been working in recommendation information systems for the last 15 years or so. I got my PhD at TU Berlin in computer science, and ever since I've been working on these things. Specifically, the keywords that I've been working on are recommender systems, information retrieval. I've been working on personalization and user modeling, and one of the sort of topics I've focused on in all those is evaluation. Anyhow, that's enough about me. Let's go to about what we'll be talking about today. So I'll start by giving you a definition of what recommender systems are, at least what the recommender systems that I'll be talking about are. Some history, some of the presently popular or important topics, and what's going on in the future of recommender systems. So what are recommender systems then? I guess many of you have seen this. Perhaps quite a lot of you have seen this as well. So Netflix is one of the sort of most commonly used applications of recommender systems. And if you read some of the literature that Netflix publishes about how their systems work, you find out that not only are they personalizing what you get to see, they are also personalizing what type of recommendation algorithms will be figuring out what it is that you want to see. Another popular application is Spotify, which probably many of you have seen as well, and they have a lot of both manually curated and automatically generated recommendations. I saw a presentation a few days ago actually from the head of something at Spotify for Benelux, and he actually mentioned that some of the sort of key automatically generated recommendations they have are these daily mixes. So those are personally tailored for the sort of target user based on what we've seen. And if you look at my daily mixes, you see that I have some interest in music, and then I have small kids that listen to music as well. And this tends to populate my recommendations. But more and more today, we're seeing recommendations come into systems that to context where we wouldn't necessarily expect them. And this is a screenshot from Shell Company, which is a large electronics chain here in Sweden that you're probably well familiar with. And they have recommendations as well. So when you browse a specific product, you get these recommendations of what you should be combining these with. And this is probably not very surprising since Amazon has been doing similar things for 20 years, right? But then again, if you look at other contexts, such as here, for grocery shopping, this is Coop, one of the large grocery shopping chains in Sweden. They actually also have recommenders nowadays. So when you browse a product, they will recommend you other products that might be relevant based on what other people who browsed this product also browsed, or what other people who bought this product also bought, and so So what we're seeing is an influx of these things into sort of our daily lives, not only trying to suggest what we should listen to or view, but what electronics we should purchase, but also what groceries we should purchase. Many of us wear wearables. You see that these things, recommender systems exist in those as well. They'll tell you to move around or do some exercise. We have recommender systems trying to help us plan our travels. But also we're seeing recommender systems and personalization systems come into the health and well-being domain. So this is the screenshot on the bottom right is from an app called Dose Medbox, which will remind people to take their medicine when it knows that, for instance, you're close to your medicine and so on. So we're seeing these systems get into our entire lives, not only in the digital space. So coming back to this picture, what is the recommender system here? Well, it's all of the things that we're being recommended as query completions. So what Google does is it automatically generates query completion suggestions based on our historical searches, based on the information it has about us and so on. So query completions, something that we might think are sort of the same for everyone, these are personally tailored towards us based on our sort of historical usage. So coming back to the definition of what a recommender system is, it's a ranked list of items. And ranked meaning item 1 is higher ranked than item 2 and so on. But also here I'd like to say that the list here it could be a list of length 1, or it could be a list of any number of items. So imagine that we're being recommended something on our phone with a limited screen real estate. We might only get a list of 1 items, and that will be ranked. So we get the top item, but it might just as well be a longer list. It's a personalized list of items. So we're getting lists that are personalized, tailored towards us, the sort of target user. It's a list of items based on the information need. So system is trying to figure out what we're after, taking into consideration things like if it is a weekday or if it's a weekend, where the information need might change. Looking at our location, are we in our office or are we at home? So the information need might change, even though we're using perhaps the same query or the same app. Taking the context into consideration. So again, if we're pulling up our phone and putting up a Google Maps, say when we're traveling abroad, our context will be different than if we're doing the same thing on the way home. So the list of items is being generated taking the presentation into consideration and also context. So by presentation, it's whether we're watching this on a device with a small screen or large screen, on a shared device or on an individual device. Generally, recommender systems are a combination of all of these above and many, many more. Moving on, let's focus on what the purpose of recommender systems is. And I like this image quite a lot to figure out what recommender systems are. Nowadays, there's a lot of information available online, and not only broadly online, but even if you go into one specific app, say we want to watch a movie on Netflix, or you want to listen to music on Spotify or whatever it is, there's endless choices to make. So what recommender systems are systems that alleviate choice overload. And what is choice overload? Then I'd like to illustrate this with a screenshot from Wikipedia, which has a nice article about information overload, which would be the sort of equivalent of choice overload when we're talking about digital devices. And what Wikipedia says is that information overload is the difficulty in understanding an issue and effectively making decisions when one has too much information. So practically, we're just overwhelmed. When we're overwhelmed with information, with choices we can make, we simply can't make them. So recommender systems try and help us with this. Okay, now that we are done with the sort of definition, let's go into a short historical recap. I'd like to mention that I won't be going into sort of the nitty-gritty details of how these systems work. I'll give you a broad overview of what algorithms are used and so on. But if you really want to go into sort of the details of it, I'll have a list of papers at the end that you can go and read. But I will not be going to the sort of the fine-grained details. Anyhow. So a historical recap of recommender systems of anything in information systems is really difficult to do, and there's many places where you can start a historical recap. I chose to start with a paper that was published in 1967 called Nearest Neighbor Pattern Classification. And I'm sure the majority of you have heard about nearest neighbor algorithms, k-nearest neighbors, and so on. And this is, the nearest neighbor algorithms, k-nearest neighbor was one of the algorithms that was very much in use in recommendation, and that sort of made recommender systems the way we work with them today possible. So I chose to start in 1967 with this paper. So for those of you who are not familiar with how KNN and nearest neighbor algorithms work, it's an algorithm that identifies near neighbors of a data point in some high-dimensional room or space. So in practice, trying to identify which data points are similar, that are close to each other based on some form of similarity. Moving on, in 1990, there was a paper published by Jussi Karlgren, who has been at 6, which is RISE now, and this is while he was at Stockholm University. And this is probably the first paper that frames recommender systems in this modern context, the way we look at recommender systems today. Jussi today still works on recommender systems at Spotify, so he's still active in this space. In 1994, there was another paper published by a group from the University of Minnesota called Group Lens, an open architecture for collaborative filtering of net news. And the key word here is collaborative filtering. This was the paper that coined collaborative filtering the way we use collaborative filtering today. And what collaborative filtering does is it attempts to identify users who are similar to each other based on interaction patterns. So if you've interacted with the same items, you will be perceived as similar. And this was the first paper that mentioned that. This was applied to a Usenet group where they attempted to identify what email messages or what Usenet messages should be relevant for whom. While this is a paper that it's almost 30 years old already, I would recommend anyone that has an interest in recommendation or information systems in general to read it, because it talks about things that are very relevant today, but with with eyeglasses from '94. It's really interesting. In 2001, there was another paper talking about collaborative filtering, and this time that paper spoke about item-based collaborative filtering. So instead of attempting to identify correlations between users that interact in similar fashions, this paper attempted to identify similar items that had been interacted with in a similar fashion. And item-based collaborative filtering has consistently outperformed user-based collaborative filtering in recommendation. While this paper was published in 2001, it was put to use on Amazon already some time before. So this was quite an interesting paper. Then moving on to 2006, Netflix launched the Netflix Prize. And perhaps some of you have heard about the Netflix Prize. The Netflix Prize was a huge challenge, a competition launched by Netflix, where they released the largest data set to that date for recommendation purposes. It contained 100 million ratings given to movies that users of Netflix had given. At this time, Netflix wasn't a streaming service. Netflix was a DVD rental service. So what you would do was you'd go to netflix.com, you'd log in as your user, and then you'd rate a few movies that you had seen on a 1 to 5 scale rating scale, and then Netflix would identify or recommend the movies that it would think that you would want to see, and simply send them home to you. You'd watch them, send them back, rate, and so on. And I think at any given point, you would be able to have like 5 DVDs at home. You'd go and rate them, you send, and whenever you send one back, they'll send you a new one. And the Netflix Prize was sort of the topic, the focus was to beat Netflix's own rating prediction algorithm by 10%. And the team that would do that would be awarded $1 million. It was set up in such a fashion that if any year during the challenge there would be no algorithm that would beat the Netflix algorithm by 10%, the top performing algorithm or the team that had the top performing algorithm would still get something like $50,000. So when the Netflix Prize was launched, this was a huge thing for the community. This was a huge thing for machine learners, and a lot of people participated. I think there were more than 2,000 teams participating in the Netflix Prize during its run. And while today, we have Kaggle and so on, this was in a time before Kaggle. This was in a time before we had these services. So when the Netflix Prize was launched, this was a huge thing. This was the first time researchers, or actually anyone, had access to real world data on users and how they interact with these systems. What the Netflix Prize also meant was that recommendation was equated with rating prediction. And this was in 2006, was also the same year that the first Recommender Systems Conference was held. So these events sort of went in parallel, and what happened was that a lot of the research that was done for the Netflix Prize got published at the Rex's conference, and in practice the entire community started doing rating prediction. So it all meant that everyone tried to identify how many stars people would give to a certain movie. And this wasn't necessarily a bad thing, because all of a sudden the entire community had the same problem to sort of work on. So there was a lot of progress being made. For instance, this paper, this was a blog post by a guy called Simon Funk. He published a blog post about his way of doing rating prediction through singular value decomposition. an algorithm that was later coined as Funk SVD. And what this meant was that rating prediction became sort of a matrix completion problem. So in practice, the factorizer would attempt to restore the user item matrix given the information that was available, and given that the user item matrix is users and items, and only the data points where a user has rated an item exist, it's a very sparse matrix. So this was a sparse matrix completion algorithm, and it worked very well. This was put to use by many different services, Netflix among others. There were a few sort of approaches that were very well received and worked very well. So, for instance, Yehuda Koren's paper on collaborative filtering with temporal dynamics started looking into this, how temporality affects recommendation, and how temporality has an actual effect on how users will rate things, and how this can be embedded into a collaborative filtering algorithm. And in the end, in 2009, the Netflix Prize concluded by a team that ultimately bet the Netflix rating prediction algorithm by 10%. And so when I say a team, this was a team effort of multiple teams. You see that the team here is called Bell Course Pragmatic Chaos. I think in the beginning there was 4 or 5 teams that all had very well performing algorithms, and they started joining in order to sort of gain spots in the leaderboard. And in the end, this was a team of 20 plus people who had a very complex set of algorithms that worked very well and bet the algorithm that Netflix were using themselves. But during the 3 years that the Netflix Prize ran, Netflix also changed from being a DVD rental company to a streaming company. And when you do streaming, these ratings aren't necessarily super important. And this was something that was brought up recently after the conclusion of the Netflix Prize, where a senior engineer at Netflix, Xavier Matrein, wrote up this interesting blog about how we're doing everything wrong, how ratings aren't necessarily what we should be focusing on. And why? Well, ultimately, it's because of this. When we have ratings, they might not necessarily mean a lot. People tend to rate either on one end or the other, or just in the middle, or they create idealistic profiles of themselves, of what they would want or how they would want to rate a certain thing, not necessarily how they actually perceived the movie or whatever it was. So at the same time that the Netflix concluded, the recommender systems landscape also changed from predicting ratings to generating rankings. And while this might not seem like a very huge thing, it actually meant that the very well-defined problem of matrix completion, which is rating prediction, went into ranking, where ranking could be based on anything. And it also meant that these very sort of structured data that we had, the ratings, weren't necessarily as useful as we would think. So all of a sudden, the recommender systems researchers and practitioners had to figure out new ways of generating recommendations, not blindly staring at, was this a 4 or was this a 5? Instead, looking at how did the person actually interact with this, looking at things like dwell time or view time, clicks, hovers, and so on. So it went from a problem where data was very well defined, the problem was sort of very well defined as well, into something that was, well, the data wasn't well defined, the quality metrics weren't well defined, and we had to look into things. So we had to look for new things on how to measure what an actual interaction was, what a successful interaction was, and so on. Nevertheless, so there was a lot of research being done, and also at the same time, what happened in the community was that we saw more and more people from other fields than machine learning and computer science come into the field, because instead of really looking at matrix completion, we would be looking at how users perceive things and so on. So going from a machine learning conference or a machine learning topic to something where you needed to take cognition into consideration, HCI into consideration, and also psychology. So it became quite a lot more complex topic all of a sudden. But along with the entire AI/machine learning communities, the recommender systems research community or in field also had a stint with deep learning. So in 2016 there was a workshop that was organized in conjunction with the Rexis conference, and this is the only time I've been at a research conference where they had to post security personnel outside of the workshop, because there were so many people trying to gain entrance to that workshop that they ultimately had to close the doors and ask people to sort of go somewhere else. It's we're at capacity, and at the same time, we had papers from Google and YouTube talking about deep neural networks for recommendations and so on. So obviously, these things made an impact in this space as well. And we had quite a lot of interesting things being generated. And one of the topics discussed back then was how you can apply deep learning algorithms to this very specific recommender systems context. And it took a few years for people to figure out how to do this. So this wasn't a trivial thing. Still, there was a lot of research being done in this field, and then in 2019 there was a paper that was published at the Recommender Systems Conference that discussed some of these things that had been published and done with neural networks, but also with machine learning in general. Specifically that many of the benchmarks that were used when publishing works about recommender systems weren't necessarily correct, and there were certain things that pointed to the progress being made in the field not being actual progress, but something that the authors here coined as phantom progress. Meaning that even though accuracy values increased, the way those accuracy values were presented or calculated weren't necessarily objective or weren't necessarily aligned with the problem. So there was a lot of debate about this, and just 2 weeks ago there was the Rexis conference again in Amsterdam. It was actually a physical conference, and there was a follow-up paper from a different group of authors discussing similar things as well. So this is still a sort of a hot potato where people are trying to figure out if we're still now 15 years after the Netflix prize and 40 years after the nearest neighbor paper, whether we're still doing things right or not. But if we look at the sort of topics that were sort of prominent at the Recommender Systems Conference this year, you see a lot of these things that are less sort of core machine learning and more talking about these things like fairness and bias and interactivity and users in focus. And this is also reflected in the machine learning community in general. We see things like responsibility, we see things like transparency being quite popular. Looking at the Gartner hype cycle for AI from last year, we see some of these things reflected here as well, where machine learning is going through this sort of it's gone past the peak of inflated expectations and is now sort of entering the trough of disillusionment, where we're trying to figure out what to actually do with these things, whereas things like responsible AI and digital ethics are becoming more and more popular or more and more important. And what's interesting about recommendation is that this is since this is an application of machine learning, of AI on a very sort of end user centered context, it's super important to look at these things like ethics and responsibility when dealing with this, because these things have actually a huge impact on end users. And one of the things that sort of is reflected in this is looking at, and I don't have a slide on that, but there's after the Netflix prize concluded, there was a challenge sort of established called the Rexis Challenge, which is a yearly competition that attracts anything from dozens to thousands of participants. And this year, Twitter was the sort of industry organizer. It's always split up between industry and academia. So there was a few academics, and Twitter was the industry organizer. And the main idea was to figure out how you do ethical and responsible recommendations on Twitter. So this is a really important topic, not only for academics reading papers, but also for these large companies that work with recommender systems. This is also reflected in things like the European Consortium or the European Commission that recently published these ethics and guidelines for trustworthy AI, where it discusses things like that the AI systems should help people making informed decisions, should be transparent, and that the data and system and AI business models need to be transparent. And this is specifically when looking at systems that work with end users. I mean, we're not talking about making some assumption about some engine data or how a combustion engine or how an electrical engine works. This is about how people actually interact with online systems. So these are things that are becoming really, really important. So these things from the European Commission also discuss things like diversity and non-discrimination, fairness, bias, and so on. These are things that we need to figure out how to embed into either the algorithms or how we can sort of work with them as data points when generating recommendations. And also things like accountability. So who's accountable when a recommender system recommends a physical exercise that hurts the target user, or when it recommends a food that the target user is allergic to, and so on. So there's a lot of things that need to be considered when working with recommender systems. And while these are examples from the European Commission, similar things are being published by, for instance, the Chinese government. So this is a report that was published in August by the Chinese government, in practice regulating how recommender systems should work or can't work when dealing with customers in China. We have things like the So GDPR, of course, and now the CCPA, the California Consumer Protection Act, which is being passed into legislation shortly in California, regulating how data and algorithms can be used when dealing with end customers. So there's a lot of things that need to be dealt with when figuring out how to recommend. It's not just the algorithms, it's not just the matrix completions or the rankings or the collaborative filtering, but thinking about how we can use all of these additional data points that we historically haven't cared about or dealt with. All of these things need to now be sort of considered when generating these recommendations. Right, there was a follow-up to the paper from 2019 about how the benchmarkings and evaluation metrics used weren't necessarily aligned with the problem. There was a follow-up to that paper in 2020, talking about embedding maps for recommender systems, and I believe that this was also a fairly controversial paper, as it posed that the way we did the way embeddings have been applied for recommendation systems weren't actually corresponding to the recommender systems problem. Instead, it was a really bad proxy of something else. But a lot of research has been published about that. So there's been a lot of talk about or discussion about these things lately. Right, so the historical recap. And some of the things that I've been working on in the last 10, 15 years, and why I've recently started focus a lot about these ethical guidelines and so on, is in 2008 I started my PhD on recommender systems, and one of the things that sort of came to mind was that the way evaluation was done wasn't necessarily right. And there was a paper from I think it's from 2009 or 2008 from the information retrieval community, debating whether the progress being made in the information retrieval community was actually valid. And that paper discussed like 10 years of papers published at the SIG-IR conference, which is the sort of premier conference for information retrieval. And I started looking at similar things in recommender systems, and it actually ended up that the Rexis community were doing similar things. When looking into evaluation, some of the things that sort of came to mind when trying to figure out how evaluation is and should be done is things like reproducibility. So a lot of the work that I've been doing in the last say 7, 8 years has been on reproducibility, mainly how we can figure out how to reproduce papers or results, or how we should write about, so as academics, as researchers, how we should publish our works in order to make them reproducible. In order to make them transparent. This is also a thing that's becoming more and more relevant as recommender and information systems are sort of transitioning from being only available on digital devices to being available in our offline works, so offline lives. So when we're talking about getting a recommendation for doing a physical activity or doing something that actually entails not just clicking on a screen, then transparency becomes a huge thing, because we really need to understand or make end users understand why we're recommending these things to them. And this also boils down to fairness. So how fairness needs to be embedded in these things. And I would like to underline that, you know, evaluation is sort of the key here. And some of the works that I've been doing in the past have been on health, foods, and well-being. So there's been a lot of work about trying to figure out how we can recommend healthier lifestyles or general well-being, how we can recommend foods taking into consideration things like instant gratification, but also the long-term things. So since when listening to a track or watching a movie is that gives the end user an instant gratification, whereas looking into well-being and you know, health, we need to transform that into a long-term gratification where we have people do these things without there being you know, a piece of candy at the same time as they're doing the activity. So there's there needs to be something that sort of translates this instant gratification and traditional recommender systems into this long-term gratification and modern recommender systems. And this sort of talks about, or this boils down into recommendations of physical items. And this is one of the sort of coming research areas when you look at what's going on in recommendation right now, is that there's a lot of stuff being done on you know, how we should think of when people purchase actual physical items, specifically in terms of also you know, sustainability. One of the things is that many of these online retailers, much of the stuff that's being sold is also being returned. So how does that? How can we use that in when actually building the recommender system? So trying to mitigate the returns that people will, you know, whether it's clothes or books or whatever, the things that people purchase that they don't need in the end. Right. So sort of the key aspects currently being researched in the Rexis space are these: so fairness, transparency, reproducibility, all under the sort of evaluation moniker. Okay, and I think I'll open up for questions now.
Thank you, Alan. Perhaps I can start with a question on sort of you ended here with some of your contributions in health and food and well-being, and you discussed the going from the instant gratification to long-term gratification. What sort of the contributions in your work here, were those on the algorithmic side, or were they on the UX side, or was it more on sort of the human side of things?
I guess all of the above or both. Some of the work I've done has sort of has shown that the evaluation metrics that we use, for instance, are really bad proxies for actual user experience. So when blending, you know, you train your algorithm and you show that it performs at a certain level of accuracy, and then you have users use the system, and then after they've used the system, when you ask them what they felt about these systems, systems that have really poor accuracy measures might actually be more well liked by users. So I've done things like that. I've looked into how we can focus various algorithms in various domains. So when talking about news and media recommendation, what type of algorithms we can and should deploy in what contexts in order to help people with their interaction. So for instance, when you're dealing with expertise communities, recommendations aren't necessarily of very good use. Whereas when you're dealing with general purpose recommendations, so daily news, there's a lot more means of improving the sort of the experience for people. So trying to figure out how can we take those things and embed them into the algorithmic side of things. So at this point, it's been studying and researching how people interact with these systems in order to later be able to figure out how this can be used from the algorithmic side. Mainly about how we can how we can express this as data points that we can use for training.
Interesting. So you started looking at the evaluation in 2008. Since then, have you seen sort of any changes in the evaluation that has also propagated through to the development of systems, which now perhaps not focusing on simple accuracy measures?
Yeah, absolutely. There's been a lot of, if you look at the community, the research community, there's a lot of like, while if you took a paper from like 10 years ago, it would do some basic offline training and offline evaluation, and then say, hey, look, my mean average precision is 6% higher. Perfect. Customers will be 6% more happy with the system. These papers don't get published nowadays. Now you need like a proper evaluation. Quite likely you'll need some online or counterfactual evaluation, trying to figure out whether the improvements made are actually valid for the end users. So there's a lot of like the evaluation processes have developed, and they've become quite a lot more complex. Which isn't necessarily, positive, but I think when looking at the research in general and the progress made, while the progress perhaps seems to have slowed down, I actually think that there's more progress. It's just that it's actual progress as opposed to optimizing on some metric that doesn't really mean anything.
Sounds good, then. Sounds like it's doing what it should. Do we have some more questions for Alan?
May I ask a question?
Yes.
Thank you. Thanks for interesting talk. Just I'm wondering, have you worked on some recommendation system that they are, I'm talking about time-aware recommendation system, because user interest might change during the time. And in deep learning approach or most machine learning approach, we just train our network at one time and we just use that many times. But people's interest during the time might change, and it's really important in recommendation system because you're going to recommend more related items to users. Is there any?
So these are the type of presentations that you'll see companies like Netflix or Spotify talk about. While this isn't necessarily something you'd write up in a research paper, since this is a very practical thing. But what usually happens in sort of the real world where these systems are applied is that you'll have a bunch of different models being trained at different times. So, for instance, if you're doing, you might have one huge model being trained on the entirety of the data you have on a user, for instance.
Mm-hmm.
That thing might be trained on a daily or weekly or even monthly basis.
Mm-hmm.
And then you have other models that are trained on more recent interactions from both that user, but also from the general public, in order to get the more recent things. And you will also look at things like giving data points that are older, giving them a lower impact. So I had this slide on time and collaborative filtering. So there was a lot of work in this field I'd say 8-10 years ago, where temporality was really analyzed, and people looked into how to the temporal effects or what effects temporality has on recommendation. And in general, I mean, you want to use, and not generalizing, you would want to use the entire data you have on a certain user, but you would also want to sort of premiere the more recent interactions, since those actually say more about the user's current tastes. And I mean, people evolve. So of course, if you look at music and movies, people will evolve, so their tastes will evolve. And if you look at e-commerce, people when people have small kids, they have certain needs. When kids grow older, they have other needs. If they don't have kids, that's an entirely different need, right? So temporality is a thing that's being used, and it's in general, it's about having various different models that you train on various different data, and you give those models more or less impact on the end on the result.
Thank you.
I think Jesper has a question.
Yeah, so this is more of a continuation of Olof's question. So in the spirit of reproducibility, I assume most researchers, especially from academia, don't have access to online systems. So kind of, is there an established way of, kind of formalized way of evaluating these things, or is it just counterfactuals, or are there other methods?
There's a lot of counterfactuals. So so Torsten Joachim has given this tutorial, I don't know, 5 or 10 times by now, on how you use counterfactuals to sort of emulate online evaluation. So that's one thing. Then there is there are some services that are available for academics, like this Rexis challenge, where this year it was Twitter. I think last year was Twitter as well. The year before was Trivago. There was Spotify a few years ago. And like, if you compete in those challenges, you actually, so for some years, you actually get to run an algorithm on the customers. Like if you go through sort of the first round. And then there's a lot of data being published by many companies, since more and more they've realized that by publishing data, they get a lot of free work done, since PhD students and so on will work on these things and will try and make use of the data. But again, this is at the it's up to the companies, and as researchers, as academic researchers, we don't have direct access to that. So it is a problem. It's a problem that's being discussed yearly at the Rexis conference and at many venues like that. And there's no.
Yeah. So are there? I was just curious because, for instance, I know at Booking.com they discussed a little bit about having, I guess you could call it a digital twin, where you kind of emulate user behavior. So is that something that's established also in recommender systems, or?
That sort of sounds like some type of counterfactual.
Yeah, but simulated. So you're learning a user behavior in some way.
Yeah. Yeah, I mean, there's a lot of so simulated data sets and simulations are, it's what it is. They're simulated. They won't get you the best paper awards at the ranked conferences. So while those things are in use, they might not be in use as much as they could be. There's been some discussion in the community recently about trying to figure out whether there's some, whether the Rexis research and practitioner communities could set up some form of simulation that could be useful for benchmarking, but there's nothing available right now.
Mm-hmm. All right, thank you.
Thank you, Alan, for this inspiring talk, and thank you everybody for attending and for discussion. So welcome back next week, the same time on Thursday. We'll have Nikunj Saunchi from Princeton University. We'll talk about theory for self-supervised learning. Thank you for today, and welcome back.